For generations, the Big Bang Theory has been widely accepted as the explanation for the origin of our universe. But what if conventional wisdom is wrong? Imagine living in a black hole, where the universe was created not by a one-time explosion, but by a continuous process that's still happening right now. Could this be the truth about the universe's inception? Join us on a journey to explore the idea of the Big Bang being debunked and the possibility of living in a black hole. In 1927, a Belgian priest and astronomer named Georges Lemaitre proposed the theory of the Big Bang. According to the theory, the universe began as a singularity, which is a single point that was extremely hot, dense, and full of energy. This singularity then rapidly expanded and cooled, resulting in the formation of subatomic particles and eventually atoms. Matter began to clump together as the universe expanded, forming clouds of gas and dust that eventually became stars and galaxies. There is plenty of evidence to back up the Big Bang Theory, including cosmic microwave background radiation, which is a faint glow that pervades the universe and is thought to be the afterglow of the Big Bang. There is also abundance of light elements like hydrogen and helium, which is consistent with Big Bang nucleosynthesis predictions. The observed large-scale structure of the universe, including distribution of galaxies and their relative velocity and location, also agrees with Big Bang Theory predictions. But truly, there is no theory that is perfect, and the Big Bang Theory is no exception. Some limitations and criticisms exist, such as the fact that it does not explain what caused the initial singularity. This has led to the development of alternative theories that sound far-fetched but are scientifically possible. One theory that is challenging the widely accepted Big Bang Theory and causing debate among scientific communities is the idea that the Big Bang was wrong and that we still live inside of a black hole. A black hole is a region in space with such strong gravitational pull that nothing, not even light, can escape. This is because of the massive amount of matter packed into such a small space, resulting in a phenomenon known as a singularity. When a massive star collapses and its core becomes compressed to an infinite density, black holes are thought to form. The origins of black hole theories can be traced back to the 18th century, when John Michell, an English astronomer, proposed the existence of objects with strong gravitational fields capable of trapping even light. It wasn't until the 20th century when scientists like Stephen Hawking developed a comprehensive understanding of black holes and their properties. Hawking proposed that black holes emit radiation, which is now known as Hawking radiation, and that this causes black holes to lose mass slowly and over time. He also proposed that information about objects falling into black holes is stored on its event horizon, which is the point of no return. Black holes can be described using general relativity equations. The theory describes the curvature of space-time caused by the presence of matter or energy. In the case of a black hole, the mass of the black hole creates a large enough curvature of space-time that anything that gets too close is pulled in and never escapes. The event horizon of a black hole is defined at the point at which the escape velocity exceeds the speed of light, making escape impossible once the event horizon is crossed. The idea of living inside of a black hole is not new and has been explored by several scientists and philosophers. One of the notable names in this field is Nikodem Poplawski, a physicist and cosmologist who has proposed that our universe is contained inside of a black hole. Julian Barber, a philosopher of science, also explored the idea that black holes may represent a fundamental aspect of reality. He has suggested that black holes could be the building blocks of the universe and that their properties could be used to understand the underlying structure of reality. This theory is based on the Holographic Principle, and it suggests that our three-dimensional universe is actually a projection or a hologram of a lower dimensional reality. In other words, all the information that constitutes our world, including all matter and energy, is stored on a two-dimensional surface that exists at the edge of a black hole. Think of it this way. Imagine you have a holographic image of a fish. When you look at the image from one angle, you see the entire fish, with its scales, fins, and eyes. But if you were to turn the image over, you would see that all the information that makes up the three-dimensional fish is actually stored on a two-dimensional surface. The image appears to be three-dimensional because of how the information is encoded on the surface. Similarly, the holographic principle suggests that the information that makes up our universe is stored on a two-dimensional surface, and the universe appears to be three-dimensional because of the way that information is encoded. The boundary of a black hole provides the two-dimensional surface where this information is stored. The observations of the universe's accelerating expansion also supports this theory. Some scientists believe this is due to the universe's gravitational pull towards a massive object at its center, such as a black hole. Observations of cosmic microwave background radiation also suggest a large concentration of mass at the center of the universe, which some interpret as evidence of a black hole. But have you ever wondered what lies beyond our observable universe's boundaries? What if our universe is just one of many, floating in a vast multiverse? This idea is supported by the concept of baby universes. A baby universe is a self-contained universe that is thought to exist within our own universe. The concept of baby universes stems from the theory that black holes can give birth to new universes. When a black hole forms, it creates a singularity, a point of infinite density and gravity. According to this theory, the laws of physics as we know them break down at this point, and it is possible that a new universe will be created within this singularity. This new universe would be entirely distinct from our own, but it would share the same physical laws and constants. This concept of baby universes is also related to the possibility that we are living inside of a black hole. According to the living in a black hole theory, the universe we observe may just be a simulation created on the surface of a black hole. If this is the case, our universe would be one of many, each existing with its own black hole singularity. But several pieces of evidence point not only to the existence of baby universes, but also towards the Big Bang. The cosmic microwave background radiation, for example, is thought to be the remains of the Big Bang and provides evidence for the existence of baby universes. The cosmic microwave background radiation is a faint glow that pervades the universe and is thought to be the Big Bang's afterglow. Baby universes, if they exist, would have their own Big Bangs and cosmic microwave background radiation. Baby universes have had a massive impact on Big Bang and black hole cosmology theories. If the baby universe theory is correct, it will alter our understanding of the universe and its origins. It would imply that the Big Bang was not a once-in-a-lifetime event, but rather a continuous process in which new universes are created within black holes. In light of this, it's interesting to consider other theories that also explain this concept. According to loop quantum gravity, LQG, a black hole creates a new region of space-time and a brand new universe. According to general relativity, the center of a black hole is a singularity, which is a mathematical point from which nothing can escape. According to LQG, the center of a black hole never quite reaches the singularity point, but instead is prevented from doing so by a force. This force then expands into a new universe, creating a white hole. The space-time from which the black hole formed and the universe it created are completely separate and do not touch, with only the black hole connecting them. All of these theories raise intriguing questions about our understanding of the universe. They go beyond general relativity and offer new perspective on the origins and nature of our universe. We hope that you have enjoyed this video. Make sure to subscribe, like the video, and watch these ones as well.